Today I'm going to talk about some thinning and fertilization experiments that we have in Scotch pine and Lodgepole pine, and I will also be talking a bit about Norway spruce. So the first presentation will be about Norway spruce and Scotch pine, and I will see if we can change slides. So, and I call this 7 myths about thinning, and so now you must not misinterpret me. I'm not at all against thinning. It might look like that when you listen to this presentation, but I'm more like we want to thin from the right reason, and I think that we have sometimes thought of thinning or doing things that it's not. And then I want first to have sort of a disclaimer that what I'm talking about now is it's an experiment where we have put out a thinning treatments in. I'm written relatively, but it's very homogeneous monocultures of Scotch pine and Norway spruce. So what I'm talking about is it has to be seen for that background that we are just talking about these monocultures. And if we were to talk about other stand structures, the conclusions could be very, very different. So if we have mixed stands with wolf trees or more heterogeneous stands, then this presentation is not at all valid. But if we look for Sweden, then Sweden is covered to 50% by forest. We have like 23 million hectares of forest, and half of that area, or half of the area that are in the stage of thinning, is actually in monocultures of Scotch pine or Norway spruce that is relatively homogeneous. And the regions here, they go from south to north. So south is number 1, and the very most northern region is number 7. And you can see that in the south we have a dominance of Norway spruce, and in the north is the dominance of Scotch pine. But we also have these mixtures of Scotch pine and Norway spruce throughout the country. It is also it's an important stand structure for us. And we have of the wood, we have about 20 or 25% of broadleaves, very often in different mixtures. So today we are talking about thinning in monocultures, but I think at least for Sweden, learning how to thin in mixed stands, it's also very, very important, maybe for the future. And then the 7 myths that I will talk about is the first one, and this is things that I think at least we were taught this in forestry school. Maybe not the first one, thinning increased growth. That is more some companies saying that because they want to buy wood from thinnings. But thinning results in larger trees. That is certainly something that we learned in forest school. Also, thinning results in higher vitality of the trees. That is also something that we think that the thinning is doing. Increase the net income at final felling. We want to create more valuable trees, and therefore higher income at final felling. We also say sometimes that we come out in the forest and say this forest needs thinning because it's so dense. I will talk about that later, but very often that is then it would be better to have an early final felling. We also in thinning, we are very concerned with the spatial distribution. We want to have the trees equally spaced on the land, and that might not always be true. And then lastly, at least in Sweden, we have thought that thinning from above is something that you should avoid, because when you thin from above, you remove the best growing trees, the genetically best trees, and that we will also examine. And to do this, we have this experiment, what we call the GG experiment. And GG is Swedish, so it stands for thinning and fertilization. So we have an experiment where we look at thinning, fertilization, and interactions between thinning and fertilization. And we have 48 sites in Scotch pine and 23 sites in Norway spruce. And I indicate the fertility of the sites by site index, and that is the height of the dominant trees, so 100 dominant trees per hectare at the age of 100 years. And so for Scotch pine, we have quite a big variability in site conditions, from site index 18 to 29. So 18 will be a relatively poor site, whereas 29 is a good Scotch pine site. For Norway spruce, we have the sites mostly in the south, where productivity is higher, and Norway spruce is also traditionally planted on better sites. So the site index varies between 29 and 37 meters. And we have lots of treatments. I will not go through all of these treatments in these presentations, but the treatments are about number of thinnings. It's also about or frequency of thinnings. It's also about the timing when you start the first thinning. It's also about how heavy thinnings you have, and then finally it's about the thinning form, thinning from above or thinning from below. I will go more into that when we come to the results. And this is for the Scotch pine, and we have almost similar treatments for Norway spruce. The only difference is that the basal area after thinning is higher in Norway spruce than it is for Scotch pine. And that was it was done when they started this experiment in the 60s. This was the tradition at that time. Nowadays we have about the same basal area of the thinning in both Norway spruce and Scotch pine. So, and the experiment was started in the 1960s. The installation of experiments ended in beginning of 1980s, and then we have followed the experiments since then. And many of the Scotch pine stands, they are still active, they are still measured, whereas the Norway spruce stands, most of them are either final felled or have been lost in wind throws. So we do not have that many Norway spruce stands today, but most of the Scotch pine stands are still measured. And the thinning treatments have been, in most cases, we are done with the thinning treatments, but they are still fertilized for the fertilization treatments. Okay, so then the first myth then, that thinning increased volume production. That is, of course, not true. You cannot increase volume production by removing trees or by removing needles from the stem. Then you will always reduce growth. So, and in this graph, this is the green one is for Scotch pine, the red one is for Norway spruce, and this I00 it stands for no thinnings and 0 in basal after thinning. Whereas this A318, it means that we have done 3 thinnings and it has been 18 square meters per hectare in basal area after thinning every time. And this middle one, then we just did 1 thinning, and then it was retained 10 square meters per hectare after this thinning, which is a very heavy thinning. It is actually against the Swedish law to do these heavy thinnings. And in the bars, the green part it is living living trees, and this lighter part of the bars, it is self-thinning. So for Scotch pine, unthinned has highest gross production, including mortality, and also a bit higher net production of living trees. But the difference between the thinned and unthinned in net production is not significant. For Norway spruce, you can see that if you compare with this normal thinning, the A treatment, it has higher net volume production than the unthinned, whereas total production, including mortality, was highest in the unthinned. So, the conclusion then is that you cannot increase total production, but you sometimes you can increase net volume production, especially if you have waiting a long time to do the final felling, if you're long rotations and get lot of self-thinning, then the unthinned mortality in unthinned might be high. The second myth, that is more difficult, and this is I've been in forestry for a very long time, and when we started, then this was the real reason for doing thinning, that we wanted to increase growth of the best trees in the stand, the trees of the best quality and others. And for Scotch pine, which is this to the left, we have the unthinned, and I put that at 1, and then the normal thinning. So then we have increased the mean diameter with 23% during the thinnings. And in Norway spruce, it's even more than that. For the normal thinning, is 36% increase in diameter. And then for this heavy thinning, the G treatment, is almost 70% higher mean diameter. But this is, of course, this is, how should I put it? It's just a mathematical thing, because what really increases the diameter in the thin treatment is because we are removing the smallest trees. So your mean diameter will increase directly after thinning. It's not something connected to growth. It's something connected to that we are removing the small trees. So for this, where we remove the dominant trees, then we are not increasing growth, we're increasing diameter. And if we look at the diameter of the 300 biggest trees, and look at the Scotch pine, then it's the thinning increases the diameter of the 300 largest trees just by 4%, almost nothing. So for the dominant trees, and also for, in our case, for the valuable trees, we are doing very little for increasing their growth. It is a bit more for Norway spruce, but still the normal thinning is just a 9% increase of the 300 largest trees. So that is what I'm saying, that we do increase mean diameter, but maybe not that much about for the dominant trees, the trees that are valuable and that we want to grow fast. But now it gets even more complicated or stupid. So if we look at diameter growth for the 300 biggest trees, red is unthinned, and these greenish lines, they are the different thinning treatment, and the darkest, so that's almost black, that is the normal thinning, or what is close to what we are doing today. And they are growing faster. The 300 biggest trees are growing faster than the 300 biggest trees in the unthinned. So now we have the difficulty of saying that the trees grow faster, but they do not get bigger, which is difficult. But if you look at the diameter development, then we have this red line. This is the unthinned, and the black one. This is the normal thinning. And at every thinning, we are reducing the size of the 300 biggest trees. So that is, at every thinning, we are removing some of the 300 biggest trees. And this removal, it could be because some of the biggest trees are damaged or in any other way a bit, you want to remove it because it has some damage or it's a bad quality trees. But in many cases, it is because they are standing close together. So you remove one big tree because you want the other big tree to develop. And I will come back to that. So then it ends up with just this small difference in diameter. So yes, they are growing faster, but maybe not that much faster than we thought they would be. Then the third myth is that thinning results in more vital forest. And that, I think, is, we do get quite a lot of damage because of thinning. Especially in Norway spruce, we have a lot of wind damage or wind felling connected to thinnings. The risk for wind felling is increasing a lot after thinning. In Norway spruce, we also get root rot connected to thinnings. We get infections in the stumps, and that is then infecting neighboring trees through roots. And we have damage from harvest machines. So trees that we want to retain after thinnings are sometimes damaged from harvesting. And this is a simulation that we did in Norway spruce. So we took the county in southern Sweden and then simulated that for 50 years. And in one simulation we had the standard thinning treatments that are applied in forest today, and compared it to unthinned. And then after 50 years, we let the storm of the size of our Gudrun-storm. The Gudrun-storm was something that happened in 2005, and it is famous for having felling a lot of forests. And in the reference, we lost about 70 or a bit more than 70 million cubic meter, which is about the same as was lost in the Gudrun-storm. But in the unthinned, it was less than 20 million cubic meter. This is, of course, a modeling exercise, so it's not measured values, but we know that unthinned stands are much more storm-farm than thin stands. So at least it's not against our hypothesis. So the myth 4 is that thinning results in higher net income at final felling. And this example is from Scots pine. But first I want to point that the mean volume per tree. Sorry, I see this is in Swedish now, but this is mean volume per tree for all harvested trees in thinnings and in final felling. And then it's 0.25 cubic meter per tree in the thin treatment, and it's 0.43 cubic meter per tree in the unthin treatment. So to get to the status where we have this high mean volume in the thin treatment, we need to remove a lot of small trees in thinning, which will reduce the mean volume, the total mean volume for all trees during the rotation. And the income, this is then the net income in Swedish crowns per hectare, in 1,000 Swedish crowns per hectare. And that is higher for the unthinned than for the thin. And this is because we have a higher volume in the unthinned. We have removed volumes in thinning. So it's not increasing the value at the final value. But this last figures, that's the net present value. And since we have some income in thinnings, then we do get a higher net present value, and that can be a real motivation sometimes for doing things. And then myth 5, it was what I was saying that very often Swedish foresters go out in the forest and say, this forest needs thinning. And that is, in most cases, not true. No forest needs thinning. The forests do not need thinning. And if there is a need for thinning, or put it another way, if there is a very high risk for self-thinning, then in most cases it's better to do an early final valley than to do the thinning, because if you thin in this very dense stands, and they have to be quite high also to be that dense, then there's a big risk for wind damage if there's a storm coming after the thinning. And then also, as I showed before, if you do a late thinning, there are no time for the retained trees to develop, so that you will not get a better stand by doing these thinnings. So very often it's just taking very high risk and not gaining anything. But sometimes as forest owners, you need to do this in order to get money out of the forest, but that is sort of another thing. This is also something that is heavily debated among Swedish foresters. How important is the spatial distribution after thinning? And we know that the dominant trees, they are very often clustered because there has been some variation during establishment. You get the fast establishment in good places, and then they will grow good and compete with smaller trees. So therefore, it's very often that you find two dominant trees growing quite close together. And if you have that, if you have two nice big trees growing close together, and you are 20 or 30 years from final felling, there is very little chance that one of these trees will be very small and very ugly in the near future. So we try to say to them that the spatial distribution is much less important than what you think when you just look at the forest. You can have good trees clustered together and then have gaps in between. And this is because, at least for the condition where I'm working, competition underground is much more important than competition above ground. And competition below ground is working on big distances. So it's not tree-to-tree competition, it's group by group. And this is a small proof of that. We have another thinning experiment where we compared corridor thinning to selective thinning. And in the corridor thinning, they just took out 2 rows of trees, whereas in the selective thinning, they tried to find as good spatial distribution as possible. And now, to the left you have Scotch pine, and to the right you have Norway spruce, and red is selective and blue is corridor. And we have stem volume at about 15 years after thinning. And as you can see, there is almost no difference between the selective and corridor, and it's far from this small difference is far from significant. It's not a total proof of that spatial distribution is not important, but it is an indication for this. And then finally, thinning from above resulting in reduced production. And this was actually such a truth that it was in the law, in the Swedish law until 1977, thinning from above was forbidden, because they thought that if you remove the big trees, then you would remove the genetically best trees from the stand, and that would reduce production. And we can say that for Scotch pine, this is not true. This is a big material, and there is absolutely no difference in thinning from above. Actually, this is a normal thinning, and this is thinning from above. So, and there are no difference at all in total production. There's an indication of difference in Norway spruce, but it is not significant. But we do not have as big material in Norway spruce either. So, and nowadays thinning from above is not restricted by in the forest law, but it's not practiced that much either. Most of the thinnings are done from below. Yes, and then finally I wanted to compare a management plan. This is a management plan done by a forester walking in the forest and subjected to attaining treatments to stands. And the yellow stands here, here he or she suggested that they should do a thinning, and the green stands, they are suggested for final felling. And then we took exactly the same area and run it through an optimization decision support system called Heureka. And I think you can see the difference, that there are much more green stands in the Heureka management plan and much fewer yellow stands in the thinning. And so in the management plan, they suggested 39 stands for thinning and 16 stands for final felling, and they were affecting 35% of the total area. Whereas for the optimization plan, only 4 stands were thinned and 28 stands were final felled, and 70% of the area was affected. So for us in Swedish forest, we often thin if it's possible. If the thinning guidelines say that this stand can be thinned, then it is suggested for thinnings. But final felling, that's a totally different question, because it's a big decision to do a final felling. And so then that is done only when you actually need the money. So again, I'm not against thinning at all, but I think that at least in Sweden, we have been routinely assigning thinning to stands just because they can be thinned. We're thinking, do they need to be thinned, or do we need to thin just this stand? Do we need the money, or do the stand? Is it a good silviculture to thin this stand? Yeah. Again, then thinning increased growth. It does not for total volume production, but sometimes it's true for net volume production when we have long rotations and lots of so-thin. Larger tree, that is true, but for the biggest trees, our rotations are too short to have a significant effect. Higher vitality could be, but we also have problems with thinnings, like these three big damages. Net income at final felling, that is very often not true for total income at final felling because you have higher volume. But in many cases, net present value and land exploitation value can be higher in the thinning compared to non-thinned. But then we should also remember that when we do this economic calculation, we assume that nothing happens, so that there are no storm damage, there are no root rot or other things that can be come after thinning. Dense forest stands has a need for thinning. No, they don't. That we can say. The forests do not have a need for thinning, and it can very often, when we see the dense stands in this homogeneous stands, they are too high and too dense, and the risk for storm damage is very, very high after these thinnings. And spatial distribution, this is of course within reasonable limits. You cannot have all the trees in one corner of the stands, but you can have much more grouped trees than what we as foresters think we can. And lastly, thinning from above reduced production, and this is not true, at least not for Scotch pine. A little bit true for spruce. And again, I want to stress that this is a homogeneous monocultures of Norway spruce and Scotch pine. And I also want to stress that I'm not saying that you should not thin, but I'm saying that you do not need to thin all the time. There's no law that we have to thin. So thinning should be done when we can see that we can improve the stands, or if it's for economical reasons. And then there are stands where thinning is needed when we want to regulate tree species composition or want to regulate stem structure or any other things. But this was for homogeneous stands. I see that I've been talking a long time, so I will very quickly talk a little bit about lodgepole pine as well. So, lodgepole pine in Sweden, that's an introduced species, of course. We started to introduce it on big scales in the 1960s, and it was in the 1970s, 80s, and 90s when it was planted really much. And we see that now. So now the standing volume of lodgepole pine is increasing quite a lot in Sweden. This is figures from the year 2004 until present. And so now lodgepole pine is the 6th biggest tree in Sweden, and a bit more than 1% of total standing volume in Sweden. So this is the same graph, but now I've divided it into diameter classes. And what's interesting here is this diameter classes between 10 and 19 centimeters, because that is where we do our thinnings. And you can see that it's these diameter classes that are increasing. So we are in urgent need of thinning guidelines for lodgepole pine, because this is a new thing. Or it's almost a new thing for us in Swedish forestry. We need to learn how to manage lodgepole pine. And then, fortunately, in the 80s, a thinning experiment and also spacing experiment was installed, mostly in northern Sweden, because that's where we have lodgepole pine. It's planted in the south too, but not at all as much as in the north. And nowadays or it was against the law. Now it's open again, so it's possible to plant lodgepole pine in the south, but it's not that popular. So we are talking about northern Sweden for new species. And we have these treatments in these thinning experiments. So we're comparing two thinnings, either were thinned around 11 meters of dominant height or 14 meters of dominant height, to one heavy thinning where 50% of the basal area was removed. And then, of course, we also have the unthinned stuff. This is just a schematic. This is not real values, but it's just showing what the thinning treatments look like. So for thinning strength or basal area removed, we have reduced volume production of the thinnings compared to the unthinned. It is, but in these experiments, it was very little difference between the removal, if you have removed 50 or 25%. I will show later that in other experiments we have a bigger difference. But it's same as for Scotch pine. Thinning reduces growth, and in this case, it also reduces net volume production. Timing of thinning, if we thin at the top height of 11 meter or 14 meter, had very little effect. So it's not that if you do an early thinning that you will reduce total volume production. And this is also the same finding as we have for the Scotch pine. Thinning from above or from below, then it's A is from above and B is from below, and this is 50% removal, 25% removal compared to the unthinned. And you see we have a little bit different result than what I showed before, because it is different plots, different experiments. We did have all the treatments in all sites, but there's some indication that the thinning from above have reduced growth, but this is not significant. Maybe because we have fewer plots or fewer sites, but also there's an indication of higher mortality in lodgepole pine in thinning from above. And this could be a difference between the three species, lodgepole pine and Scotch pine. This is looking at the mean diameter of the largest trees. So it's sorted from the 100 largest trees, 200, 300, 400, and 500 largest trees. And then I'm comparing 50% in one thinning, 25% in two thinnings, and then the unthinned. And as you can see, as for Scotch pine, very little difference when you look at the dominant trees in diameter development. This has not, we do not have as long time between thinnings and measurements as we had in Scotch pine. These experiments are younger, but the tendency is the same. And then we have this. This was a big storm, Dagmar, that happened in the Christmas of 2011. And this is one of the experiments, actually, that I was talking about. We were looking at the experiments, and many of the experiments looked like this. They were totally failed by this storm Dagmar. I'll come back to that one. So then lastly, some words about fertilization of lodgepole pine. We started experiments in 2009 where we took 12 large stands, and then in each stand we divided that stand into two parts. One was fertilized and one was unfertilized. One was to control. And fertilization was done from airplanes, and it was with 150 kilos of nitrogen. And then we put out circular sample plot to measure the trees, and we measured them 2 times, 2009 and 2011. And then at the Christmas Eve of 2011, then Dagmar came and there were no more measurements in this experiment. But yeah, this is just showing that we had about the same starting values. This is the mean values for all the stands. There are some variation in individual stands between the pairs, but the mean was very similar. And in volume growth, this is just 2 years of measurements, and it's showing yearly growth. And then the mean value, this one out here, is it was unexpectedly a big difference between. So we were very happy when we found it, when we got this result. We thought this is a very good response to thinning. It is very significant. But then the same storm came to this area as well in the Christmas of 2011, and we got this result that it was a very clear effect of fertilization, that fertilized areas have more wind felling than unfertilized. In mean, it was a little bit less than 20% for unfertilized and more than 40% for fertilized. This result has, from this experiment, has actually resulted in that it's very little fertilization done in Lodgepole pine in Sweden. I think that we might have been unlucky that this storm came in exactly the right time for making a big difference between fertilized and control. At that time when we had a big development of needles in the fertilized, but not the development of roots. So it was just when they were as unstable as possible. So maybe that fertilization in lodgepole pine is a bit has a bit too bad rumor in Sweden than it should have, and it is because of this experiment. But the thinning, that the recommendations that we have now is to make an early fur thinning as early as possible, not to cost too much money. And this is done because of wind felling, that we want to avoid severe wind felling. It is very rare to do more than 2 thinnings. Very often it's just this the first or the first thinning. And we have many stands that are managed without thinnings, and in stands that are in topography that are wind exposed, then the foresters can choose not to thin. And also in stands, in bad quality stands, because in some of the early plantations, they were using poor seedling types, and they were also planting lodgepole pine on sites where it's not suited. So we have quite a number of sites with very poor quality, and that is not thinned either. And as I said, we are not doing almost any fertilization in lodgepole pine in Sweden, even though we think that the response could be quite good. And this is done with very little experimental data. So I would like to revisit this and see if fertilization can be done. And then rotation length for our planted lodgepole pine is an open question. We are not there yet. Some stands have been kind of felled, but we do not know how sustainable growth is in these planted stands.